all of you are doing well. Now in today's session we are going to be continuing from where we had left off previously. We are going to be talking about types of fractions today. Alright, in the previous session we had learned all about what fractions are, how they represent parts of a whole. Okay, numerator, denominator, all of these things we had discussed. Today we will be discussing regarding types of fractions. Okay. Now, first let us discuss regarding like and unlike fractions. Okay, what are like and unlike fractions? Let us discuss. Now, when both the fraction, when we are comparing two different fractions, okay, when both the fractions have same denominator, you can see it is written here. Like fractions means they should have the same denominator. Okay, the bottom number, there is a denominator that is those numbers should be same. Okay, unlike fractions, on the other hand, they have different denominators. Got it? Like for example, 3 over 5 and 2 over 5, they are like fractions because they have both 5 as the denominator. Here we can use our interactive simulation to learn more about them. Okay, let us check it out. Now, if I click on this show example button, okay, it is showing us different groups of fractions. Here you can see 1 by 4 versus 2 by 4. Okay, what do you think? Are they like fractions or unlike fractions? They are like fractions because both of them have the same denominator, right? Now, let us put some numbers on our own. Instead of 4 here, if I make this as 5, all right, now let us check. Okay, let us compare now. When we click the compare button, yeah, you can see here they are unlike fractions. The denominators are different. Okay, they are clearly different. You can see here 4 versus 5. The first one has 4 as the denominator, the second one has 5 as the denominator. Okay, now on the basis of what we have studied till now, okay, can we have some questions now? Okay, now which pair shows like fraction, students? On the right hand side, you can see in the test your knowledge section, we are going to be clicking the option which says the correct answer. Which pair shows like fractions? The first pair, second one, third one, or the fourth one? Okay, first one, as we can see here, see, correct? Because like fractions have the same denominators. In the first one we have 2 by 5 and 3 by 5. Okay, the denominators are same, but in all the other options we can see the denominators are different of those fractions. So the second, third and fourth options will be incorrect. All right, next question. What makes fractions unlike fractions? How do we know that fractions are unlike fractions? Different denominators or same denominators or different numerators, equal values? What will be the answer, students? The answer is going to be different denominators. All right, now another one. Which pair shows unlike fractions now? See carefully. Unlike fractions. Remember unlike fractions? Okay, I'll give you a hint. When the fractions have different denominators, which of these have different denominators? Again, option number, the first one, 1 by 6 and 5 by 8. Okay, 6 versus 8, different denominators. All right. Now we have learned all about like and unlike fractions. Let us now talk about proper versus improper fractions. Okay, now when the numerator and denominator, we're not comparing fractions anymore. We are going to be seeing that if a single fraction is proper or improper. Now here 1 by 2, here we can see that the numerator is 1 and the denominator is 2. Okay, the numerator should be less than the denominator, as you can see here written. Okay, when the numerator is smaller than the denominator, then it is going to be called as a proper fraction. Okay, it is a proper fraction. Now if I write here 3 instead of 2, now what will happen? Okay, let us check. See, now it has become an improper fraction. 3 is greater than or equal to 2, so it is going to become an improper fractions. Okay, 3 by 2 means 1 whole and 1 over 2. Okay, it is a mixed number. We're going to be talking about mixed fractions next. Okay, what is happening here actually? Our fraction that we entered now, 3 over 2, it is improper because 3 is greater than 2. Okay, it equals 1 whole and 1 by 2 parts. Got it? Next, let us talk about mixed fraction now. Okay. Now students, in order to understand mixed fractions, let us play a game here. Okay, we're going to be adding a box. Okay, one box. You can see that one box has 4 different circles, right, or candies you can say. Now if I add another part here, what does it represent? You can see it represents one whole box and 1/4 of that box. All right. If I add another part here, now what the fraction becomes, you can see it is changing. 1 whole and 2/4. Okay, one whole box we have, and out of another box we have 2 out of 4 chocolates or 2 out of 4 candies. Now if I add one more candy to it, we have one whole box of candy and another 3/4 box of candy. Now, what if I add another candy to it? What happens now? We have 2 complete boxes of candy. Very important. Okay, let us start over. Let us start in another way. We add only one part, or we can add one candy. We can add another candy. It becomes 2 over 4. If I add another chocolate or another candy, it becomes 3 out of 4 or 3/4 box. Next, if I add the fourth one, it becomes one whole. So it completes the entire box. So if I add another part, it becomes a mixed fraction. Okay, we have a whole part and we have a fractional part, that is called mixed fraction. All right. If I keep on adding the boxes, if I keep on adding the chocolates or candies, you can see that the mixed fraction is changing. Right. Now we have 2 boxes and one more part. 2 boxes, 2 whole boxes and 1/4. 2 whole boxes and 2/4. 2 whole boxes and 3/4, and so on. Let me add another box here. It becomes 4 boxes, 5 boxes. Right? Now, what is happening? Now, each whole box contains 4 candies, right? Let us start over. Each whole box contains 4 candies. Now, for example, if you see one whole 2 over 4, that means I have to add one whole box and I have to add 2 more candies to make it one whole 2 over 4. Got it, students? So mixed fraction means we should have one whole part and we should have a fractional part. Now, let us talk about equivalent fraction, students. Okay, very interesting. Here again, we have our pizza. Now, if I cut this pizza in half, okay, and if I cut this pizza to 4 different parts, now to 6 different parts, to 8 different parts, to 10 different parts, you can see whatever part has been highlighted in red, it is remaining the same or not. That means technically if I say, okay, this, that is half, is same as this one also, because we are selecting 2 parts out of 4, that means we are selecting half of it. If I have a 6-piece pizza, we are selecting here in the red zone, you can see we have selected 3 out of 6, then again which can be called as a half. If I cut it in 8 different pieces, right, 8 different pieces, again we have selected 4 out of 8, that means again we have selected half. So 1 over 2, and same thing with 10 also, 5 out of 10 we have selected, you can see 1, 2, 3, 4, 5, 5 out of 10, that means again half. So 1 over 2, 2 over 4, 3 over 6, 4 over 8, 5 over 10, all of these fractions are same. They are equivalent to each other. That means they represent the exact same amount of pizza. Okay, so notice, you can see, what do you observe here? How different fractions can represent the same amount of pizza. Right? The colored slice and bar, they show the equivalent fractions. Equivalent fractions, they represent the same portion of a whole, even if they look different. Now, these are obviously a different fraction, they are looking different. But as we can see here, everything, all of them, they are representing the exact same piece of pizza or not? They are representing the exact same piece. Okay, half, 2 over 4, 3 over 6, 4 over 8, they are exactly amount to half of that pizza. So all of these are equivalent fraction. That means those fractions are same. All right. So that would be all for today's session, students. In the coming sessions, we are going to be studying about the remaining topics.